This is Machamp, my personal favourite Pokémon. Machamp resemble a human figure, except for the fact that they boast over twice as many arms as the average human. I'll stick to the metric system for this video, but don't worry, there will be alternate units on screen for all you Imperial lovers. Machamp measures in at a reasonable 1.6 meters, and weighs 130 kilograms. That's the same weight as 2 average humans, or 1.5 average Americans. Machamp is a Pokémon that just loves helping out, especially with manual labour. That means it's strong, but just how strong? For that we turn to the Pokédex. The first entry we have is from Gen 1, where the Pokémon was introduced. In Pokémon Red and Blue, we are told that using its heavy muscles, it throws powerful punches that can send the victim clear over the horizon. That sounds pretty impressive, but just how far is the horizon? In order to find this, we need to first think about why we have a horizon. After all, on a day of perfect visibility on flat ground, there's no reason as to why your vision would stop, because there's nothing in the way. And while this is true, hopefully the fact that the Earth is round comes as no surprise to you. If we draw an observer on, it immediately becomes obvious that their vision stops at a given distance. From the image, we can also intuitively tell that the height of the observer will affect how far they can see, with smaller observers being able to see less far. From scale diagrams of Machamp, we see that their eyes are 1.5 meters above the ground. From some simple geometry, we can create a formula for the distance to the horizon, and find it to be 4.4 kilometers for the average Machamp. That's pretty far, but the real question is, how fast would you have to be thrown to clear the horizon? Ignoring air resistance, because let's be honest, nobody cares about air resistance, we can use the fact that 45 degrees is the optimal throwing angle, and make ourselves another formula. From this, we see Machamp would have to throw you at 750 kilometers an hour, or 460 miles an hour. That's about 6 times the motorway speed limit. Still, 3.5 times slower than a bullet shot from an AK-47. Air resistance is very much not negligible in this situation, but that doesn't really matter, for reasons I'll explain. We can work out the average acceleration Machamp would have to exert on your body if we know the distance over which you are accelerated. This is the length of Machamp's arm, about 0.8 meters. We use another formula to get an acceleration of 27,000 meters per second square. That's 2,800 Gs. That means you would experience a force 2,800 times of the gravitational force the Earth exerts on your body in your day-to-day life. That means you're dead. Kenny Brack holds the limit for the most Gs ever survived at 214. You're over the limit by 13 times there. So, what does this tell us about how strong Machamp is? Well, if we take the victim to be an average 80 kilogram human, Machamp has to exert a force of 2.2 million newtons to throw them over the horizon. That's pretty strong. But the Pokédex entry just states, the victim. So let's take the heaviest Pokémon there is, Snorlax. Weighing in at an impressive 460 kilograms. To punch this boy, Machamp needs 12.4 million newtons of force. During this throw, Snorlax would gain 10 megajoules of energy in only 7.7 milliseconds, giving Machamp a power output of 1.3 billion watts, which is 1.7 million horsepower. That is the equivalent of the average power consumption of the entirety of Finland. I mean, sure, it's only over a short throw, but that is still a lot of power. And then Pokemon Ruby tells us that Machamp leaps into action before it thinks. Not a great combination. But it gets better. For in Pokemon Fire Red and Pokemon Diamond, we are told that it can launch 1,000 punches in just 2 seconds. Let's think about that. We know from before that Machamp has an arm length of 0.8 meters. Let's assume a punch means it has to extend its arm fully in, fully out, and fully back in again. And for simplicity's sake, let's take the punch to be a triangle, meaning the arm starts at rest, then it reaches a top speed somewhere in the middle of the punch, and then goes back to rest. As Machamp has 4 arms, each arm has to do 250 punches in these 2 seconds, so each punch takes 8 milliseconds. This clocks the maximum speed of Machamp's arm at 400 meters per second, or Mach 1.2, which means that every one of Machamp's punches breaks the sound barrier and would produce a sonic boom. The arm retraction also makes a sonic boom, meaning you would hear 2,000 sonic booms in just 2 seconds. Impressive. But it gets better. Pokemon Sun goes on to say that Machamp unleashes Megaton level punches. To throw Snorlax over the horizon, we worked out that Machamp would require 10 megajoules of energy, which is the equivalent of 2.4 kilograms of TNT. A megaton is defined to be 1 million kilograms of TNT. That is 4.2 quadrillion joules. Weighing in at 460 kilograms, we can use the formula for kinetic energy to see that Snorlax would be flowing with a final speed of 15 million kilometers an hour, or 9.5 million miles an hour. This means our poor Snorlax is about to get yeeted with a speed that is 1.5% the speed of light itself. In this case, clearing the horizon is the least of Snorlax's worries. But it gets better. For in Pokemon Let's Go Pikachu and Eevee, we are told that one arm alone can move mountains. Right. To begin, we need to define what exactly a mountain is. From Wikipedia, we see a rather Wikipedia-esque definition. In this, I see 3 important bits. It must have a summit, be larger than a hill, but that's not very helpful, and it must be at least 300 meters tall. For the purposes of our experiment, we will sever the mountain at sea level and have Machamp lift it. This is because lifting the mountain and moving it would almost certainly require less force than pushing it along the ground. Very crudely, as physics is sometimes, we will take all mountains to be cones. Then we have a straightforward formula for their volume. With this, we can use the density of the Earth's crust to find the mass of the mountain, and so the force required to lift it. The smallest mountain I could find by my definition is Manger Mountain in Auckland. Apologies for any incorrect pronunciation. It towers at a whopping 351 meters over the surrounding town, and has a base with a radius of about 400 meters. This means Machamp would need a force of 1.6 trillion newtons to lift it. 1.6 trillion is way more than the 12.4 million newtons that was needed to throw Snorlax over the horizon. And this was the smallest mountain I could find. If we trek deep into the Himalayas, we find Mount Everest, the highest peak on Earth. It stands at a very well documented 8,848 meters above sea level, but its width is a little more difficult to measure as it's found in the middle of a mountain range. After much deliberation, I decided 5 kilometers was a good estimate, meaning 6 quadrillion newtons of force would be required to move Mount Everest. And this is with one arm alone. All 4 arms have a combined output of 24 quadrillion newtons, enough to lift 11 million loaded cargo ships or 44,000 Great Walls of China. I am pretty certain they didn't check the math when they wrote this Pokédex, because Machamp is one very, very strong boy.